Hello, learners. Uh, Welcome to the first lecture on Internet of Things. So, myself, Kumar from Department of ECE, Assistant Professor, at Marri Laxman Institute of Technology and Management, Dundigal, Hyderabad. So, coming to the very first lecture on IoT. First of all, what is IoT? So, in 1999, Mr. Kevin Austin, he's a pioneer industrialist in Britain, he coined a word called IoT. He proposed that if we empower the computers such a way that they can see or they can sense or they can smell by taking decisions, by taking data from various devices, they can take decisions themselves. That is IoT. So he proposed it in 1999. So coming to the very first part, what is actually a IoT? So normally a IoT is a combination of various sensor devices, such as a temperature sensor or a humidity sensor, soil moisture sensor, or any different physical device or an endpoint device which is connected to a smartphone or any computer or anything, or even you can choose a Raspberry Pi or any controller normally. So these combination along with the endpoint devices and Raspberry Pi or a controller together performs a fantastic task that will treat it as a Internet of Things. So remember to communicate these sensors with the various devices. So we need to use a connectivity methods. So connectivity may be or different types of communication protocols we have. We'll study about these communication protocols in due course. So before that, we may use any type of communication, might be a Ethernet or a LAN or a coaxial cable or a twisted pair or a RJ45 cable, whatever. So any connectivity cable, and this connectivity cable is used to connect the sensor devices with the various components. So these various components and sensors will be connected using this connectivity protocol, right? And whatever data we assume or we collected from the various sensor devices will be processed and stored in various physical storage devices or any cloud. If you need it, we can even choose clouds for storing it, and these clouds, they may process the data based on user requirement, or they may take a decision based on user requirement. So this data processing will be done by a computer or any IoT controlling device. So coming to the next, normally where we are using this IoT devices as of now. So I can say in many places nowadays we are using IoT devices. I'm just mentioning here list top MNC companies where the IoT is used, right? So first and foremost, IBM. In IBM and Google, Intel, Microsoft, and Cisco, they are the top MNC companies listed in the world nowadays. So these companies, to provide services to their employees, to their customers, so they are using IoT technologies. Nowadays, they are using IoT technologies, right? And specifically, if I want to mention the applications of IoT, so IoT applications are very broad. I can say many applications we have. So I came up with a classification, or I can say they are all called as domain specific IoT applications. I repeat my statement, IoT having lot of applications in different areas. So that's the reason we classified them as domain specific IoT applications. About these domain specific IoT applications, we'll speak again in due courses. So we'll speak again in coming classes. So before that, let me just give a glimpse of these applications. The very first one is home automation. So nowadays, automatic control of various small appliances, light intensity, detection of any harmful gases, security purpose, we are using these IoTs. And we are also using in the cities such as traffic control, parking management, and the different applications, structural management. There also we are using IoT. Coming to the environmental. So in the environment, to detect the what is a percentage of moisture in the environment, and what is the amount of various toxic gases which are present in this environment. So for that also, right, we are using IoT. So along with this, we are also using energy, such as how much of energy is generated in power stations and how much amount of energy is distributed to various grids, and preparing consolidated reports or generation of bills, etc. There also we are using energy, IoT devices. So, and then logistics. So, transportation, such as preparing route maps, scheduling routes, right? Even we can observe various applications such as Uber or Ola. They also comes under logistic management. So, there also we are using IoT. And apart from this, we have very familiar applications in area of agriculture. So in this agriculture area, right, nowadays we are using greenhouse monitoring and we are using smart irrigation systems. So to prevent human intervention in agriculture field, or to reduce the human intervention in agriculture field, we are involving IoT to make our work very simple. So such as monitoring soil moisture levels and maintaining water levels consistently in a particular field. Okay, and even in industry. So monitoring employees' data and detecting any machine faults, or diagnosing machine faults, and estimating prognosis reports. And apart from this, any detection in any harmful gases or toxic gases, if it is related to any biomedical application related industry. So apart from this, we have one more area, and that is called retail. So in the retail also we are using IoT. Retail means in normal supermarkets we are using card based payments, credit card, debit card, or simple swiping type machines, or QR code based payments. All these payments are also using, in that payments we're also using IoT. So this is the broad applications of IoT. In due course, again, we'll study in detail about this applications in coming lectures. Okay, so let's come into the what are the contents I'm going to discuss in this syllabus, in this subject. So I'll start very first with the introduction part. So we'll continue after this, and after introduction we'll start what are the technologies which are interconnected with the IoT. For example, wireless sensor networks. In the wireless sensor networks, IoT plays a crucial role. Even we have big data analytics, and we have cloud computing. So these are the various technologies where IoT is embedded or interconnected. And next, we are also studying a couple of Python packages because to develop any IoT application, we'll take Python as a programming language, and we'll also use a couple of devices such as Raspberry Pi or Arduino. So they are called IoT physical devices. And then communication between IoT to machine communication means how two IoT devices will be communicated, and how machine and machine. So there is a machine here. So let me call it as M1, and there is one more machine here, and this is called M2. How these two machines will be communicated, right? We may use different communication protocols here. So whatever communication protocol you are implementing, but based on this communication protocol, how these two machines will be communicated. So that also comes under the next part. And domain specific applications, as now I mentioned, 9 different domains: home automation, retail, logistics, cities, etc. So these domain applications detailedly, and various physical servers and cloud offerings what we have. So we are dealing with the various clouds, right? And some dedicated IoT cloud such as Django, or different frameworks, Django, and cloud such as Zively. So this Zively cloud is a familiar open source cloud powered by Google. So in due course, we are going to study about the Zively cloud. And at last, we'll end up this lecture series by discussing a couple of case studies. We'll include home automation and agriculture. So two regular case studies we are going to study in this. So these case studies will see in detail with the help of various Python web application frameworks in detail. Okay, so these are the contents. Clear? So we'll see one by one in this due course. So let me give a brief intro about introduction to IoT. Right. So before in what is a IoT definition, we already see now, right? And coming to the characteristics, means if I bring a network which is a combination of a network, and this network is connected, I repeat, this network is connected, right, with the support of some IoT mechanism. Now how can you say that this particular mechanism or this particular network is a IoT network? How can you say this an IoT network? How can you decide it as a IoT network? So to decide this network, so we are having some specific characteristics. So if the given network satisfies the mentioned characteristics, and then only I can say it as a IoT network. So very first one is your IoT network must be a dynamic and self-adapting. So dynamic means it has to be changed time to time based on the scenario or based on the operating conditions, and it must be a self-adapting. Whatever changes are happening in the devices or in the end sites, it has to be accepted as such, as well as the data was received. And the second for most important characteristic is self configuring. So all the IoT devices must configure themselves based on day to day, because if you observe any mobile phone, so these mobile phones will be detects your auto updation, and they will take a confirmation from you for the auto update. So this is, I told you, smartphone is also one of the part of IoT device, also one of the IoT device. So the best example is detecting uh, self configuration or auto updating softwares and configuring according to that. Okay, so this is a second important parameter. The third characteristics is interoperable communication protocols, means different communication devices we are using. So this is one device, device 1 I'm calling, and this is other device, device 2, and this is your device 3 for suppose, and this is device 4. So in this device 1 to 2, I'm using Ethernet cable. Okay, from device 2 to device 3, I'm using RJ45 jock. Okay, and device 3 to device 4, I'm using USB communication protocol, and device 1 to device 2, I'm using a coaxial cable, right? So coaxial cable. So remember, from different devices, from D1 to D2 or D2 to D3 or D3 to D4, from device to device, the mode of communication is changing. So they should be operatable within the given communication. So they have to accept the communication protocol. Then they have to configure such a way that it has to be ready to receive the or to process the data, whatever they are accepting from different devices. So this is the third foremost point, and the fourth one is unique identity. So every IoT device, right? So in the example I mentioned different IoT devices. So these IoT devices will have a unique ID number. I repeat, unique identity. We'll also call them as unique IDs, or unique IP addresses we can also call. So unique IP address, so we also call them as URIs. So every IoT device must possesses with a unique ID and or URI. So that is a fourth parameter. And the last one is all the devices which you are connecting in the IoT, they should perform the integration of all the devices should perform a specific task. Otherwise, integrated. So otherwise, no use of integration of all the components, right? So this integrated into a information network to perform some information, to perform some specific task, it has to do this. So this is a fifth point what we have, right? So this is about what are the characteristics of IoT devices. Let me continue with the generic block diagram of IoT device. So what is mean by generic block diagram? So normally we have a block diagram, but this generic block diagram is a basic components which includes any IoT device. So remember, these devices, I repeat, these devices may not present in every application of your IoT. but in some other application they may present. For example, right, if I take temperature monitoring sensor IoT application, or home automation sensor, home automation for intrusion detection, means I have my home. In this, I fixed a camera here to detect the intrusion, means who came inside. So to detect this, for that I don't need any audio jack. It's optional to record the audio voice. So audio jack might be necessary, but it's not mandatory, right? So this device may occur or may not occur, and I may use any protocol to connect the devices. I may use high definition multimedia interface HDMI cable, or I may use RCA video cable to process the videos and audios, or sometimes I may use this 3 mm audio jack, right, where we have every mobile phone on the top or bottom we have a audio socket, right? That is your 3.5 mm audio jack. So these are the various audio video processing uh, components. So they are also optional in some applications. I may have one. In some application I may have all. In some other applications I may not have anything. Based on the IoT application, these blocks may vary, right? So normally a generic block diagram will consist of this block diagram which I mentioned here, right? First and foremost block is connectivity block. So in the connectivity block we have a USB port. Not only USB, you have other options too. You can use coaxial, you can use Ethernet cable, you can use IEEE, various protocols we have. So various IEEE protocols, whatever communication protocols we have, we can use any one among them. Here I mentioned IEEE and Ethernet, right? Ethernet cable or RJ45, radio jack 45. So anything. And the next one, a processor, right? So processor means you may use a CPU. If I'm handled with a personal computer, it is a CPU. If I handle with any mobile phone, then it is a Android operating system or Android processor. So that depends on the application, right? And various audio video interfacing devices. So it might be a HDMI cable, or it might be a 3.5 mm audio jack, or it might be a RCA video cable, anything. So nowadays we are using only these two. This RCA is not available nowadays because it's an olden days. It's around 15 years old technology. So right now we are not preferring it. We are using only this. Or it might be a wireless technology also. Sometimes you may use Bluetooth for processing this, or sometimes you may use, right, other Wi-Fi or wireless technology, right? Next, memory interfaces. So different memory interfaces to store the programming data or various components. So we may use any type of programming interfaces, maybe a DDR or basic logic gates, memory devices, memory interfaces, right? And if needed, we can use graphic processing unit or GPUs based on the applications. And storage, so to maintain the storage devices, we may use SD cards, or we may use MMC cards, and we may use standard, right? So DI, standard SDIO devices. So that depends on your own applications, remember? And to communicate various components what we have, I repeat, so to communicate whatever the various components we have, right? So based on the components, the interfacing of components using various communication protocols, I may use UART, right? Universal asynchronous and receiver transmitter, or I may use SPI, serial peripheral interface, right? Or I may use I2C communication protocol, or I may use CAN. So that completely depends on my own applications. So they are the generic blocks which are present in your, right, every IoT device, in your IoT device. So remember, these blocks are not necessary in every any IoT application, but some of them are mandatory, right? So they are not necessary, but if you use based on your application. So we'll continue the remaining in session 2. Thank you.